let's look at homeworks on rules of inference, but the propositional part. Today in the lecture you heard about quantified statements, and this then also helps you for preparing for the next quiz on this topic. So I told you do 9e, but for 9e only prove one thing. Now let's read what it says. As we're doing this, I'm going to already... well, what is the first thing that we need to do? How do you tackle a problem? That is to give names. And so we have all these statements. What is good for a corporation? So to be good for a corporation, so C is good for corporation. Now you can call this P. Why not? You can P and Q if you like to use your letters in order. I tend to use letters that somehow remind me. I take the C of corporation, and the next one is what is good for. It's good for the United States. To be good for the United States, so I take good for the US. I make it U. Then I know it's US. And then the next one is what is good for you. So you. Let's take a Y. Good for you. And then there's the last clause that is inferred to is by buying a lot of stuff. So B is. Buy a lot. Let me just say it that way. Okay, so that's step one, is making these choices. That's just arbitrary here. You can give names whatever you want. But it's important. It sets everything up. Now we can start formulating each of these statements. What is good for corporations is good for the United States. Now, the problem with this is that it doesn't sound like any logical implications. Is it an and? Is it an or? Is it a then? If then? It doesn't sound like anything like that, and that's because English, I'm just saying English, but any language is much richer than formal language. And so in order to figure this out, what I would suggest is try to reformulate these things in your own words. What is good for a corporation is good for the United States. What does that mean? That means that if it's good for the corporation, then it is good for the United States. I made it an if-then, so that's what it is. Good for the corporations. If good for the corporations, then good for the US. And then it becomes eventually also good with the next one is what is good for the United States is good for you, right? If it's good for the United States, it's good for you. So U implies Y. And then the following statement says what is good for corporations is for you to buy lots of stuff. Now here you might be tempted. Okay, so C, what is good for corporations, B, but let's read what this sentence says, because it sounds almost as the same as the previous sentences, but it is English, and English things can be very subtle. What is good for corporations is for you to buy lots of stuff. So is it here, if it's good for corporations, then you buy a lot of stuff? That's not what this sentence is trying to say, right? This is, when I write it this way, it would, if I would formulated this back, I would say, if it's good for a corporation, then I should buy a lot. No, that's not what it says at all. So what is it saying then? So, okay, let me make it clear that this is wrong. But I wanted to show you that it sounds like the previous sentences and therefore would follow the same structure, but it isn't. Because what it really says is what is good for corporations is for you to buy lots of stuff. So it actually, it switches the order around. If you buy a lot of stuff, it's good for corporations. That's what this is saying. So if you buy a lot of stuff, it's good for corporations. And it helps, therefore, if you think it's right, so let's just read now what you formally have written. You can always can reinterpret these formal symbols into English, right? By just saying if then. If B, if I buy a lot, if you buy a lot, then, the arrow, it's good for corporations. What is good for corporations is for you to buy a lot of stuff. That's exactly what the sentence was saying. So this is the correct. Let me sketch it out so that we see. And now what we need to do, step 3, I will always tell you, I don't say find out. So what I ask you to do is prove that buying stuff is good for you and for the S. So it means that buying, then good for you and good for the US. So we have to do something more here. So what do we have? Well, let's see. What can we do with implications? Well, there's a lot that you can do. If you look at the rules of inference, a lot of them are involving implications. But some of the one of the rules that we often use is modus ponens and modus tollens, require you to know at least one of these, or the negation of one of these hypotheses or conclusion. But that's not the case. All three here are implications, and there's really then only one rule, if you look at the rules of inference, that is applicable, that is hypothetical syllogism. That says, if the first thing implies the second thing, and the second thing implies the third thing, well, you can go from the first to the third. Then the first implies the third. And we have changed like that, right? From B we came to C, and from C to U. So let me write this. I'm copy this one under here. It's always, each time that you use a statement, copy it, and then put the two statements that you use in your rules of inference together and say, okay, these two imply B then U, and then also always mark on the side or wherever it is somehow clearly that that you're using, if it's one of these that have names, hypothetical syllogism. Okay, the other ones also have names. If you want to use the name, you're free to use them. You can always go and look it up. But okay, so that's good. B then U. Well, I needed that, but I needed B then Y and U. How am I going to get that one? Okay, so the next thing that I want to do is perhaps, how can I go from B to Y? Well, I see that right away now, because if I use my from B to U and then U implies Y, if I put those together, I'm going to get a similar thing again. So I'm copying this one here, U then Y. And so from this, I can, by the same hypothetical syllogism, conclude that B implies Y. So we have now basically the two things we want, right? So let me put them in green here. I have B implies U and B implies Y. So why is it then that B implies Y and U? Now, that is perhaps that is also, it's a valid rule, and that rule is it's sometimes called, well, it's not really marked in our as a separate rule here, but it is clearly correct, right? If B implies one thing and B implies the other thing, then it implies both of these things. So I don't have a name for this, and I agree, therefore it is kind of a bit an outlier here. I wanted to do this particular problem because I thought you're gonna have otherwise problems with this. So what we have here is if you want a new rule of inference that we can use. Now, if you look back at the rules of inference, they all are based on tautologies, right? So this would mean the tautology that we seek to prove then is if B implies U and B implies Y, then B implies Y and U. So if we know that this is a tautology, then the rule that I'm saying that these two green things here together imply this thing is true. And this is a tautology, what I wrote down. And how do you verify that this is a tautology? By making the truth table. Okay, there's three variables here, B, U, and Y. Okay, you can do P, Q, and R if you like to do that. And so in other words, you can basically prove new rules of inference. And the way that you do that is by writing down the tautology, or the suspected, what you hope to be the tautology that proves your rules of inference. Now, I hope that it is convincing enough to say it this way. I will not ask you to use a rule of inference that we have not yet seen and that has not been mentioned in the book, but I just wanted to show you that these things are possible. Okay, so I want to do number 35. It's also a little bit of a mouthful, so I'm gonna again start. It's about Superman. So if Superman, but it's all if then, so it's clear then that what we are doing with implications. If Superman were able and willing to prevent evil. Now that is a bit of a problem. So A is able to prevent evil. W is willing to prevent evil, because that's of course two different things, right? You might be very You would be able to because you're the president of the United States, but you're not willing because you're whatever. Okay, so AW, then if Superman were unable to prevent evil, well, that's a negation of something here. He would be impotent. Okay, so I is impotent. Here the word impotent is really, in its original sense, potent being strong, being able to do something. Impotent is not able. It's just a negation. It's not. It doesn't refer to an ed here. If he were unwilling to prevent evil, that would be negation of W. He would be malevolent. Malevolent. It's, if you want to analyze this word a bit, mal is like maladie, or it's not male. It means bad in French or in Latin based languages, and volent is willing, from will. So ill will. Somebody who is, wishes somebody bad things. Now, Superman doesn't prevent evil. Okay, that we can say that. If Superman exists, so that's called S Superman, or if he exists, he is neither impotent nor malevolent, right? Now notice that each of these statements makes sense, right? And if he exists, if there is a Superman, he is not going to be impotent, right? Because we know he's Superman, and if he's not going to be malevolent. So the conclusion is Superman does not exist. So that's okay. So our step one was again giving names, but the crucial thing, or the main thing, is to get all the implications here, or all the, not implications necessarily, all the formal logical statements. So the first one, if Superman were able and willing to prevent evil, so A and W, then what? He would do so. So, we actually have not done this, and that is, let's call this P, is to prevent evil. Now you say, yeah, but Professor, we're using able to prevent evil, but there are different things. To be able to prevent, to be willing to prevent, and to actually prevent. Okay? So they have nothing to do with each other. Well, of course, they have some things to do with each other, but a priori, these things are independent. Okay? So I forgot. That's also another thing when you start analyzing, you see, oh, I might have forgotten something. You also have to be careful that it is not a negation of something that you already have, but I don't think so. Okay. Then, if Superman were unable to prevent evil, so not able, what then? He would be impotent. If he were unwilling, so not willing, so if he's say, I can do it, but I'm not going to do it, that's being exactly malevolent. So M. Superman does not prevent evil. Yeah, because even if you look at the world, there's still a lot of evil in the world, whether he exists or not, whether we are on Earth. I forget now which Earth that Superman lives, Earth 36 or 16, I forget now. Okay, if Superman exists, Superman does not prevent evil. So it doesn't prevent evil, so not P. Okay? But notice preventing evil is not the same as fighting evil, right? It is all about preventing. So it's a subtle argument, but okay, let's go on. If Superman exists, he is neither impotent nor malevolent. So if he exists, no, we call that E, right? Sorry, okay, that was a very awkward written E. So let me do that E here, and then also, oops, this is an E. If Superman exists, he is neither impotent, so not impotent, and not malevolent. No. Okay. Here, yes, I was thinking a little bit, because nor is a negation of an or. And so I'm thinking, what does it be here? Is it trying to say this, or is it trying to say this? Let's think about it. It could be either one, right? Because it's a negation of an or. Well, it trying to say this. If Superman exists, he's not impotent and he's not malevolent. The other one would be weaker. If he's impotent, if he exists, then he is not impotent or he's not malevolent. But it could be that he is impotent, and that's not definitely what we want. So it is clearly the format that I had written down is the correct one. So that's all what we have. Now we have to start deducing things. Now, okay, what we're looking for is always, do we have at least one truth that we know about one of these propositions? And yes, we do. That is this one here. And so from, okay, sorry, oh, I forgot somehow the main step, really, the real thing is now after that, what do I want to show? Because if you just blindly start proving things, you can end up God knows where. So what do you want to show? Superman doesn't exist, so not E. That's what I want. Okay, so there were two things. You can go forward, say whatever, I start creating things from things that I know. But much wiser is to try to think backwards. I want to say something about E. Do I have any information about E? Yes, I have this information about E. So in order to deduce this E here, remember in an implication, you can get the hypothesis. Not really. You can get the negative of the hypothesis by negating this thing. That's modus tollens. Or you can get the conclusion if you know the hypothesis. Now, so what we want is actually, since we want something about E, and so we need something about I and M. Now, these two are about I and M. Again, Here, they are both hypotheses, so I actually need these two guys. How can I get these two guys? Well, they both appear in here, so hopefully from this I can deduce it. How would I be able to deduce it from this thing? Since there are hypotheses, the only thing I can think of is modus tollens, that is finding the negation of this thing. Okay, so let's do this. Okay. So I have a strategy. I'm going to start from not P. And so again, I'm copying each of the statements that I have. Come on, guys. Copying is not a bit. You have all the time of the whole day long to do this test, so it's not a big deal to copy a few lines, right? So this one I'm going to use modus. Oh, sorry. I should want to write this here. Modus tollens. Remember, this is the statement that what does it do? It says that if you have an implication and the conclusion, you know the conclusion to be false, then the hypothesis must be false. So from this we can conclude not A and W. Okay. However, what does this now do? I hope by now I have convinced you that when you have a negation of something, it's hard to parse unless you push the negation all the way to the predicates, because you know what the negation of exist is not exist, and the negative of preventing evil is not preventing evil. That is easy, but things with ands and ors and ifs and thens, so we want to do this. We make this logically equivalent to, and then what is it that we use here? The Morgan law, right? And this means you take the negation of A, you take the negation of W, but then you get an or, and conjunct. The and switch into O. So I write the Morgan. Yeah, so each time that you use a rule, it has if it has a name, if it's not an obvious rule, please say so. Which rule it is that you use. Okay, so. And then my next strategy was to use these things to conclude this. Now the problem is there's an or here. And from an or, you cannot really conclude that, which, you know, it's one of the two, but you don't know one. Now, I have already given you an example. What you need to do in these cases is to split into cases. Sorry for the double use of that word. We're going to continue a proof by looking at two cases. So case one will be that we're in the situation that A does not hold, and in case two, is the other one, not W. And if in both cases I can reach my conclusion, then I have gotten what I wanted. Okay, so let's go with not A. Now, not A, once I have not A, it is clear what I'm going to use this, right? I was going to use this, it's all set up for it now. So let me copy it here, not A, then I. So by regular modus ponens, well, regular, straightforward, I can now conclude I. Good. And okay, I don't know what to do with that anymore, because with I was going to use this, so to use this here to conclude this, but I have I, okay, and I know that I need to talk about negation of this thing, but okay, okay, so, okay. I'm kind of stuck now. I cannot keep going to where I want. Well, if you're stuck at one place, then you go to another place. That's sometimes the strategy. Let's see what I can do with the not W. Well, I can do something with the not W as well. This kind of same thing that I was thinking of. Not W implies M. So again, I can do modus tollens, modus ponens, and conclude M. Okay. So in the first case, I concluded I. In the second case, I concluded M. So what I can be sure of, I cannot be sure that it's in the first case or in the second case, but I can always say from this I can conclude I or M. Okay? This is again perhaps a rule of inference that we have not exactly formulated like this. I forget now because there are so many that I didn't look at all of them. It is kind of, yes. Okay, the correct way to do this, but I think we all agree that this is a valid conclusion. But the correct way to do is at this point here, at this point say, from this I can conclude this. This is called, it has a name, so I'm going to tell you, addition. It says if I holds, then you can also, then I or M holds. And you can do this similarly here. If M holds, then I or M or I or M holds. So in either case, I know that I or M is true. Not I and M. That's not true, but I or M is true in either case. This means, therefore, I can conclude, since it's either this case or in this case, from both cases, it follows now that I or M. Is that going to help me? Let's see. What do I need? The last piece of the puzzle is this guy. I need, it's an implication, and I want to conclude that this is not true, because actually that's really what I want, right? So I need to make sure that the conclusion is false. Now, what is this conclusion? And in other words, what is this? Well, I had I or M. What's the negation of that? So perhaps let's look what is the negation of this. Now, so not I or M is logically equivalent, but not I and not M, by the Morgan law. Okay, that's true what I said, but I want to say it in a way that makes perhaps I know I don't want to do a shortcut here. Let me say what you know. What I want is I want to apply. So my idea is, let me phrase it again. Apply modus ponens, modus tollens on this one. So for that I need the negation of this. So let's write down what the negation of that is. So not I and not M. What is that? That's logically equivalent with, okay, the negation goes through, but it switches, right? It's not I or not M. But double negation is just nothing. So I or M. So what I have here is that I or M is logically equivalent to this thing. And I know I of M, so I know now this one. Now, of course, my real reasoning has to go that way. If I want to do a nice proof, then I start from I or M. Then I say I or M is logically equivalent to this guy on the left here. But it is sometimes certain rules reading backwards are harder than forward. But in principle, remember these are equalities or equivalences. You can read them in either direction. It's not always means that they are easy in either direction, but they are the same in either. They are the same, so they can be used in either direction. Okay, so long story short, what I've gotten now is that I have, let me make it green, that I know that this to be true. And I also have this, so that is an implication of which the conclusion is false. So by using these two greens, I'm going to make myself a little bit easier, putting these two together in modus tollens, I can now conclude not E. And that's exactly what I wanted. That's what I wanted. It is all rules of inference, but it is a little bit more putting things a little bit nicer together. And that is, of course, how complicated things can be. And I think, to me, this is actually, although it's a bit tougher, I like this because it kind of tells you, okay, using logic, you can actually make some kind of conclusions that you would not otherwise expect to be making. We are actually proving here that Superman does not exist. And nobody had any objection with the previous statements. So all these previous statements you accept. If you accept all those, then your conclusion must be Superman does not exist. Okay? Now, the more audacious of you guys might replace Superman by God, and then you get into a different realm. I don't want to go there, right? But okay. So here you see some applications of propositional rules of inference. But if you see the review that I will give, I do only one question, it is going to be slightly more straightforward. I say slightly because it is formal logic. This involves this kind of thing. All right.